Okay, for this deep dive, let's unpack this. This really specialized piece of engineering. The Thor Broadcast H-4HDMI-DVBT-IPLL.
That name is a mouthful.
It really is. But our mission here is to get to the core of it. How this one box can act as a kind of universal translator.
Yeah.
It takes standard video sources, like a camera feed or a presentation, and turns it all into a custom broadcast-ready RF channel.
And it sends it right over the coaxial cables you already have in the walls.
Exactly.
What's really fascinating, though, is that you're looking at a single chassis that's a genuine triple threat. It's not doing things one after the other.
Right, it's all simultaneous.
It's working as a high-quality video encoder, a DVB-T modulator, and a full IPTV streaming server. All at the same time. It's bridging three very different worlds.
And the feature that it genuinely changes the game is that ultra-low latency. We have to talk about the speed.
You do.
Why is shaving off milliseconds so critical with this kind of professional gear?
Well, it's the difference between just monitoring video and actually using it for real-time control. Most standard encoders have this massive delay.
Like over a second, right?
Oh, yeah. Typically somewhere between 1,200 to 1,600 milliseconds. That delay makes live interaction, like, say, for remote surgery or controlling a machine. It makes it totally unusable.
I see.
This unit is engineered to crush that down to a lightning-fast 70 to 250 milliseconds in a live scenario that is virtually instantaneous.
Wow. So to get that kind of speed and quality, the backbone has to be incredibly flexible. How do the engineers pack 4 heavy-duty functions into one box?
4, right. Encoder, modulator, IPTV, and an ASI mux.
All in one chassis without, signal integrity going out the window.
It comes down to really smart integration. The versatility is built into the inputs and outputs. You get 4 separate HDMI inputs, and then, crucially, that single ASI input.
So, for the listener, what exactly is an ASI mux?
Think of it as a professional routing standard. An ASI mux, or asynchronous serial interface multiplexer, lets you combine several independent video streams into one. It gives you that pro-level flexibility.
Got it. And the outputs mirror that.
They do. You can output to DVB-T to IPTV streaming, and you have an ASI output as well. And it's all controlled remotely through a simple web server.
So we know it's fast, we know it's flexible, but what about the actual picture? The sources say perfect HD quality video, up to 1080p 60. What's working underneath to maintain that?
That quality comes from really robust encoding. It uses the big codecs, either MPEG-2 or the more modern H.264.
And you can control the bitrate.
Completely. Anywhere from a tiny 0.5 up to 19.5 mBps.
Yes.
So you can set a constant bitrate, a CBR, for absolute reliability, or use a variable bitrate, VBR, to get the absolute best picture quality if you have the bandwidth.
And then how does it get that digital signal onto an old copper cable?
That's the modulation step. It uses standards like QAM16, QAM54, or QPFK to translate all that digital data into a waveform the existing cable network can actually carry.
Which brings us right to scalability. This isn't just for one screen. You can build out an entire distribution system with these.
Full headend.
Yeah.
A full headend.
Exactly. The units themselves come in 1 to 4 channel versions, but building a system with dozens of channels is surprisingly simple. You just stack the units.
Just stack them?
You stack them, and then you can either daisy chain the RF inputs and outputs, or use a simple external combiner. It makes system integration so much easier.
So the bottom line for the user is
What?
This is a professional TAA-compliant device, costs about $4,000, and it's built for powerful, high-density, super-fast video distribution.
And this really shows you where modern distribution is going. It's the nexus point. You have traditional broadcast standards, DVB-T, QAM modulation, running right alongside modern IP protocol.
Like RTP and RTSP?
RTP, RTSP, IGMP, multicast, yeah. It's a complete bridge between the broadcast world and the IT world, all inside one box. So here's the thought I want to leave with you. If one piece of hardware can so seamlessly bridge traditional RF channels and modern IP network streaming for these high-density, low-latency applications, how long until every coaxial network that already exists in a hospital, a hotel, a corporate campus becomes an entirely custom, high-speed, and dynamically controlled content delivery system?